Hello and welcome to York Observatory's monthly Teletube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Allan I Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every last Friday of the month at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at Yorku Observatory and Facebook at Allan I Carswell Ops. We would like to inform you about the opening and call for applications for the Astronomer in Residence program in January 2025. Currently, the AIR applications are closed, but if you're interested, please visit our website at yorku.ca/science/observatory/AIR for more information. Good evening, everyone. I'm Maheen, and tonight I am joined by the director of the Allan I Carswell Observatory, Dr. Elena Hyde, my colleagues Hector and Dave, and special guest speakers Arnold, Brody, and Swapna Shrivastava. And we're here from the Allan I Carswell Observatory at York University. Tonight, we have a special episode featuring the current observatory fundraiser, information on prizes, some great astronomy news items, and two talks, so stay tuned. Before we get started with our main show, I would like to mention that the observatory at your campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaranto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. I will now hand it over to Dr. Elena Hyde to get us started with some great fundraiser news.
Thank you, Maheen. It is, as you say, great fundraiser news, current fundraiser ongoing at the Allan I Carswell Observatory. If you hadn't heard, that's why we're doing this special episode. So we're actually running a fundraiser all throughout November, December, all the way to January 5th, 2025. This is a special fundraising effort, different from other fundraising you might have heard of. This is a designated campaign. We've got extra observatory tours and activities. They're all going to be supported by donors like you, I suppose, listeners. And a few awesome benefits of this being an actual campaign are that we have free extra tours and events like this one, awesome swag. So I don't know if it's coming across, but we have t-shirts. We have new 2025 astrophotography calendars coming in, lots of great things, as well as amazing raffles. So I always get the question of why donate to the observatory? Well, I love it. It's the telescopes are amazing, but the Allan I Carswell Observatory has some really unique features. Did you know, for example, that the largest telescope on any Canadian campus is actually here at York University? It is in the Allan I Carswell Observatory. It's the 1 meter. Our fundraiser this year through, as I say, January 5th, is going to support repairs, research, and free public student observing nights. So awesome for everyone. And you don't even have to be there in person. It also supports Zoom/YouTube events. We have class observing and, of course, lots and lots of great things. The current two raffles are for a private tour of the observatory for you and up to 5 others, or a supported observing run. And the third raffle is coming soon. This will be a special swag bundle, including a very hard to get book recently printed by 2 Canadian astronomers. So that's a little bit of TBA for the future. You can enter the 2 current raffles right now on the website. And the website is here. It's our same website. You've probably heard it a million times, yorku.ca/science/observatory. And you either put a /AICO fundraiser or you just click on the fundraiser link from the main page. We are, of course, largely run by volunteers, and donations help us pay our undergrads and do amazing things like continue doing free tours and refurbish the 40 centimeter, which is one of the goals. So if you're interested in reading about some of the extended goals, we have if we hit, I believe, the fourth stretch goal, and you'll have to check the website to see, we'll also have a refit for the 60 centimeter telescope, the oldest telescope that we have. And of course, paid student research positions, open research projects, and there are free prizes at every goal. If we hit the first goal of $5,000, we're actually putting our astronomically accurate fortune teller for free download on the website. And if you want to see the campaign, it's yorku.ca/science/observatory, and then you click on the fundraiser, or you just add /AICO fundraiser and go there directly. All the online donations are tax deductible, and of course, coming into, I believe, Giving Tuesday next week, tax deductible donations are great. We also have all of our cool swag items for sale online at the Yorku bookstore, as well as in person on campus. So Christmas shop in style, t-shirts, posters, zippable canvas tote bags, big coffee mugs. Basically all of my favorite things are available. And we hope that you guys can join in. So we have a bunch of events planned in. This is our first online fundraising YouTube broadcast, and we will have a second in December. Each time we get to a goal that's on the site, let's say the first goal is 5,000 Canadian dollars, we will draw a new raffle draw prize from both raffles. So we'll have one winner if we hit the first goal, two winners if we hit the second goal, three winners if we hit the third goal. If we hit the fourth goal, we'll have to have a massive party. So if you have any questions or just general queries, you can always email observe@yorku.ca. And if you have specific questions about the fundraiser, you can email me, the director, Dr. Hyde, and Hyde@yorku.ca. That's also on the website. So just to get us started, thinking about the observatory and some of the fun things that we do, I thought, what better way to start off a fundraiser area than to ask a little bit of a question. So this is a question for any of our YouTube watchers and anyone who wants to give a guess. So this is actually down on the bottom here. You can probably see it. It says an observatory riddle. Can you guess? And the riddle is, why is the observatory such an inspirational place? And I will just preface this to say all of the riddles are astronomically based. So I'll go ahead and give people on YouTube just a chance to think about it. Why is the observatory such an inspirational place? And I'm actually going to just go a little bit out of order here and take a guess from one of our guest speakers. Arnold, Brody, I know you're back there. Would you like to unmute and take a little guess on this one?
Let's see. An observatory, an inspirational. Well, I think if I went to an observatory, I'd probably be looking up. And so maybe everybody at an observatory would be inspired to look up. Something like that, maybe.
That's a great answer. Yeah. And I think the official answer we put, which is, I must say, very flexible, is everything is always looking up. And that's, of course, what you said as well. If you go into an observatory, you're going to want to look up because the telescopes are pointed up out through the open domes. And of course, looking out through the open domes, the telescopes are also looking up. So it is everything always looking up, or everyone always looking up. You can say it's a very optimistic sort of, or inspirational / optimistic place.
Well,
So
that's
thank you,
great.
Arnold.
What did I win?
You win a chance to come observing on any Wednesday night because we're open every Wednesday for public observing over here at the observatory.
Awesome.
And
Thank you.
if it is clear, we do open the domes, and then everyone can look up as well. So that's a great, thank you. All right, so thanks Arnold for hopping in on that one. As I say, we'll have a couple little quizzes here. It looks like we don't have any correct answers on YouTube yet. So if you do watch this as a recording, make sure to put your answer or your adjusted answer into YouTube chat and or as a comment if it is a rendered recording after we're done going live. All right, so next up, I want to just go ahead and have a little bit of fun before we get started on our guest speakers. I thought, given the wonderful talks that we have scheduled tonight, it might also be nice just to remind people what's up in the sky. So, what's up in the sky this week is a lot, actually. If only the Toronto skies were clear. Um, so we have a lot of great stuff. This is, in case anyone is wondering, if you're watching live, around 7:41 p.m. Eastern Time in Toronto. Around about 7 p.m., we had lovely sets of planets out. And, in particular, we have just, sort of a great planetary evening in the east just after sunset around 6 o'clock tonight. So just a little bit ago, we actually had Venus setting just as Jupiter was rising, which is kind of cool. And if you missed it, that's all right. Jupiter is actually just going to get better and better and better as the night goes on. It's still in the east, getting higher and higher. And if, of course, the sky is clear, fingers crossed, you probably will be able to see it even in downtown Toronto. I want to give honorable note to Saturn as well, which will be excellent until it sets around midnight, at which point Mars will be up. So if you really want to stay up late and you have any chance of the skies clearing, there's always that. This time of year, there's just so many wonderful long nights and a lot to see, weather allowing. While the bright planets can even be seen from the city, dimmer stars often suffer from light pollution. So as always, if you're in Toronto or anywhere in Ontario or listening to this anywhere in the world and planning to go stargazing, probably making your way to a park or a darker sky site is always recommended. Planet-wise tonight, we actually have Uranus out as well, just above Jupiter, and Neptune out closer to Saturn. But I will note that both of those objects really do require some assistance to see. Good binoculars or a small telescope is generally the way to go. Now, a shout out as well for tonight, winter constellation of Orion. It's actually just barely kind of rising around 7. It's not all the way out yet, but it'll get there. And because, of course, Orion is the winter constellation, it's going to be getting better and better as the season goes on. And Orion, it has just a wonderful tour. It has the Orion Nebula, the red star Betelgeuse, the blue star Rigel, the striking belt stars, which are excellent for orienting star hopping adventures across the sky if you have a planisphere. And as a little extra treat, that's something you won't see tonight, a rare black moon, which is actually happening tomorrow on the 30th. So today is the 29th for the live broadcast. November 30th, 2024, we will have a black moon in Canada. And this is 1 month later, the rest of the world will actually have it. So this is something of a little bit of a unique regional effect. And this is a little bit interesting because black moon is something we don't often talk about. There are actually two main definitions used. There's a monthly and a seasonal black moon, just to make things confusing. November 30th black moon, which is tomorrow, is a monthly black moon where the second new moon in a single calendar month occurs. So you have two new moons, and the second one is the black moon. So kind of the opposite of a blue moon. A seasonal black moon is the third new moon in a season of 4 new moons, just to make everyone's eyes cross a little. Both definitions are the counterpart to the blue moon definitions. And like any other new moon, they will not be visible. So black moons are invisible in the sky. And this is because, of course, the moon is between the Earth and the sun. Over on the sunny side, and us on the night side, we don't see it. And if you're on the sunny side, the sun is quite bright. And of course, the unilluminated side facing Earth, so you don't generally see it at all, or maybe just a tiny bit if you get some reflected light. This is great news for stargazers and all of those wonderful planets I talked about before. So hooray! Tomorrow, during this moon phase, no moon lights up the night, which is perfect for looking at the stars and planets. A black moon is not an official astronomical term, so just watch out using it. but it refers to rare new moon occurrences in our calendar. And because it's defined as the exact moment when the sun, the moon, and the earth are aligned, black moons can happen in different months because, of course, our modern calendar doesn't exactly line up with celestial things anymore. Monthly black moons are the most common and happen about every 29 months, while seasonal black moons happen about every 33 months. There's a rare occurrence you can kind of look up and see when your next chance will be, where you have either no new moon or no full moon in February. And that can also sometimes be called a black moon, just to make everyone really confused. And that only happens about once every 19 years. So, all this great stuff up in the sky. How are we going to deal with it? Well, I thought on our way to figuring out and getting into our first guest talk, I would just go ahead and pause and ask maybe one more observatory riddle on the way. So we've just talked about our What's Up Tonight for November 29th. So the next observatory riddle, and this is at the bottom of the slide if you're reading along, can you guess what fills up but never spills? And just to kind of go in order, I might actually ask Swapna, do you want to unmute and guess on this riddle?
Hmm. So when I'm on watching the sky through a telescope, honestly, I feel with glee.
Filled with glee. Filled
I'm
with
filled
glee.
with glee.
That's a great. So you're filled with glee, and glee. I guess it can't spill, right? So how would glee spill? That's a wonderful, wonderful, wonderful guess. Thank you. What fills up but never spills?
From
Now
a
in this,
from a moon perspective, maybe the moon. How's that? How's that from
yeah,
an astronomical
yeah,
perspective?
from an astronomical perspective, looking at the sky, and of course looking at what various effects we can see, the moon is actually the official answer, but I like yours as well. So we can gleefully watch the moon, and the moon, of course, does get full. And I have not seen it spill, although there is, of course, the sample return missions, but we won't count those. um, so thank you. But yeah, for anyone playing along in YouTube, the official answer would be the moon, but we will take gleefully watching the moon as a second answer. So we don't have any guesses for that riddle yet, but if you are playing along from the recording, you can always put it into the comments. All right, so thanks for playing along. Now to get to our first invited guest talk for this special fundraising broadcast, I'm very, very pleased to be able to go ahead and introduce Arnold Brody, who actually took a guess at one of the earlier riddles, as you might remember. So we are lucky enough to have an amazing RASC presence tonight at the AICO Teletube. Arnold Brody is the RASC Toronto Centre Coordinator for the Durham, sorry, I hope I'm saying Durham right, Durham Region Outreach Team, and his talk title is roughly Tools and Tips. And Arnold is self-taught on astronomy and has actively participated in astronomy education and outreach for 15 years, I think a bit more in Durham region. He's currently serving in the RASC Toronto Centre as the coordinator, and as it says up there, the Durham Region Outreach Team. He is connecting with us from his home in Whitby and has provided many, many Sky This Month and similar talks on RASC Toronto Centre, especially RANS. So they are recorded, and I think everyone should go watch them because they're very, very good. All of these Sky This Month and similar talks have a huge range of wonderful tools. And so he has collected some of those, and he collects astronomy information with these tools about what's up, what's actually visible, how to see it, and he's going to actually share some of those wonderful tools with us. So I'm very, very happy to have Arnold here today. So Arnold, go ahead and turn on your video and microphone, please, and share your screen. We'll get you on to your screen share, and I'm very excited to see your talk this evening.
Hello, do you hear me fine? And do you see my screen all right?
Yes, it looks amazing and we can hear you great. Thank you.
Oh, that's great. That's good. All right, I'm just adjusting my own screen layout here so I can see what I'm supposed to say. All right. So, hello everyone, and thank you, Elena, for inviting me to York University's AICO meeting. Elena asked if I would discuss some of those tools that I use in preparing Star Talks and offer a few tips. But please note that some of my tips may not be what others prefer when developing their presentations. We all have our preferences, so the tips I'll be suggesting are simply mine. You may have different preferences, and that's fine too. In other words, I'm not trying to step on anybody's toes. Now, here are some of the tools I use on my Windows desktop. Here I'm using a bulleted list. Now, there are times when a bulleted lists are appropriate, but I typically try to avoid them when possible. I believe that your audience will tend to read them instead of listening to you. And compared to images and things with motion, I find bullets a little bit less interesting, and some may fall asleep, especially after a hard day at work. Here are the same tools described in pictures. I find pictures more entertaining. They will hold your audience attention. And when giving talks on the sky for November recently, I mentioned the highlights to look forward to. And instead of a bulleted list, I used images and videos. Following is that slide using the curtains slide transition, and I'll narrate it the way I did when giving this talk. This month, with early sunsets and late sunrises, we can see constellations spanning the summer, fall, and winter seasons throughout the night. Also this month, Venus, the evening star, rises higher. Comet Tsuchi-Shan Atlas also climbs higher. Uranus reaches opposition while Jupiter approaches its own. We get another supermoon, and the sun is as active as ever. There are also meteor showers and 3 lunar occultations coming up, so this month is excellent for sky watching. Now, most of us use PowerPoint. If you explore the program's features and options, you can be creative and accomplish 2 objectives: convey what you are trying to explain and keep your audience entertained and focused. This example depicts the movement of Comet C2023A3. Using Starry Night Pro's export feature, I prepared a video of the comet's celestial path during November, imported it into PowerPoint, then added text boxes to provide dates. Using Stellarium's ocular view feature, I took a screenshot of this image to give a suggested view of the comet and NGC 6756 on December the 1st. In my Stellarium, I have built an inventory of popular telescopes, eyepieces, Barlows, and binoculars, so I can give suggested views of what one might see using popular optics he or she might have. Be prepared to spend time on your presentation if you choose to add numerous elements and animations to them. That comet slide we just saw involved 17 objects and 15 animation steps and many test plays of the animations to correct sequences and adjust timings. This slide explains why stars rise 4 minutes earlier each night, resulting in the annual parade of the constellations. We have an imported royalty-free clip art of Earth looking down over the North Pole. With a click, arrows, text boxes, and a free beanie guy appear to explain what's going on. When it's local noon for a given location on Earth, Beanie on the night side looks straight up or at a given azimuth at star A. Notice how Earth spins 360 degrees counterclockwise as it moves 1 day in its orbit. Then text boxes and shapes appear to explain how an extra 4 minutes of rotation is needed to bring the same location to Earth to local noon. I'll let it play out here. It's not playing out, so I'll just move on. Oh, there it is. Now here's how Earth turned and moved. Notice a faded Earth. I'll carry on here. Yes. Notice a faded Earth and shadow at the day one location and how the shadow half circle slowly rotated to be perpendicular to the Sun-Earth line. And with another click, Earth turns another 4 minutes to bring the original location to local noon. Here are the 11 elements needed for that demonstration. There weren't dots around the night shadow. I'm just adding them here so you can see them. With clip art Earth chosen in the selection pane, we see that it has two animations: follow a custom path and at the same time spin. Both animations start together and last the same time. Their animation bars are the same length, which in this case is 2 seconds. The custom path is slightly curved to match the orbit arc and has a green end for the start position and a red arrowhead marking the stop position here and there. The other curved path with green and red ends is for the shadow partial circle, which takes a path parallel to Earth's while rotating enough to be perpendicular to the sun. The shadow is only half as wide as Earth, so its path is offset. All right. The effect options selected for the spin are full spin and counterclockwise. As you see here, full spin and counterclockwise. The shadow is rotated 20 degrees at this exaggerated scale, so it appears perpendicular to the sun at day 2. I simply had to play with this number, 20. There is this custom box here, so you can adjust how much. And I played with that until I found the right number to get the shadow perpendicular to the sun rays. Now, notice the names given to the different elements in the selection pane over here. If you replace when you add a shape to your slide, PowerPoint will give it a default name like text box 1 or oval 1 or picture 1. If you replace default names with meaningful descriptive names, it becomes much easier to set up your animations. You can read the sequence in the animation pane and understand what's happening. If I hadn't changed the default names, the first 2 actions following a path and rotate would be for picture 1. That doesn't help. If you copy and paste the shape, the new shape will have the exact same name in the selection pane. If you add animation to both the old and new shapes, you can't tell which one you're applying the animation to, and it becomes nearly impossible to fix anything. But if you give your shapes unique and meaningful names, debugging your animation becomes a breeze. These are a few of the effects you can implement with PowerPoint. In other words, you can use PowerPoint or you can really use PowerPoint. 2 more PowerPoint tips. Use 16:9 slide size. If you have old presentations in 4:3 format, you can change them to 16:9 by selecting Design, Slide Size, then Widescreen. And all of your slides will suddenly become 16:9. You can then step through your slides to reposition or enlarge images to take advantage of the bigger slides. Personally, I like to avoid white or bright backgrounds. In my opinion, I find them hard on the eyes. At least I find them hard on my eyes. I like to find a dark background because I believe they're easier on the eyes. You may already be selecting dark formats on your cell phone, PCs, and tablets where dark screens are being offered, and I believe it's for this same reason. Now, this particular background came from wallpaperscraft.com. Notice the Unsplash license, which means it's totally free to use. You don't need to ask or seek permission. And there are a lot of choices on this particular website. One of the tools I listed is Starry Night Pro. Their latest version is 8. It's a purchased product coming in different strengths and price points. The the Pro version I use cost $160 US, so it's not cheap. But I like the ability SNP offers of viewing the cosmos from any location, not just from Earth, as is the case in Stellarium. I use it to show the location of the planets and how they will move during the month. For example, here again with the curtain transition, there we see how the planets were positioned at the beginning of the month of November. And then during the month, Mercury reaches greatest elongation. And then later on in the month, here are the position of the inner planets and their distances in elongation from the sun are shown here. Here I have Starry Night Pro and Stellarium running together to animate the moon eclipse in May of 2022 when it was totally overcast here, I might add. Now, I tried to match the clock speed in the two simulations so the shadow lines cross the moon in Stellarium at the same time the moon is passing through the penumbra and umbra in the SNP video. SNP 8 offers advanced local path and celestial path options that provide flexibility and on-screen information. Options include whether to show path lines with dots, together, or just the line, or just the dots, as seen here on the right, whether to mark positions every nth day or every single day, and whether to provide dates. The dots can be very informative. Dots for a superior planet will be widely separated when the planet is at opposition and will squeeze together as it approaches and leaves retrograde motion. Dots for a comet will space farther apart near perigee. Virtual Moon Atlas is a free program for Windows, Mac, and Linux. It features high-resolution images of the near side with imagery from the LRO. The Lunar Reconnaissance Orbiter was used specifically for low sun angle shadowing. Older versions sometimes showed the shadows backwards, so they fixed that problem, and everything is excellent now, and it's an excellent source for getting nice images to put into your presentation. For example, here's a close-up of Rupus Recta. Notice how how crisp the image is, and the details highlighted by the shadows in the terrain and crater walls. Useful information for your talk are provided as well. I use Screen Recorder Pro. It's used for capturing Stellarium videos that I can then plop into the PowerPoint. Film and TV comes with Windows, and I use it for trimming videos. I may capture video and it's too long. I can use Film and TV to trim it down to the size I need. And the third tool here is Nap Labs. And it's awesome animations from the University of Nebraska-Lincoln. You can search for it, University of Nebraska-Lincoln, Astronomy Simulations. That's how I did it. Or UNL Astronomy. That should help you as well. And here is that list. Look at all of these items here that you can use, capture with your video capture program, and drop it into your presentation. For example, if I take a look at, let's see, one of these here, the Zodiac Simulator. You can actually grab this and turn it around and imitate what's going on. In other words, the dark side of Earth will see these constellations while these are hidden in the sunlight. Seeing there's the sun. You can grab the bar here and just drag it. Come on. There we go. That's just one of them. There are so many others that you can have fun with. I'll just grab one more and call it a talk. Moon phases and the horizon. Again, you can grab the circles, play with them. You can move the latitude and longitude, all kinds of good stuff you can play with here. And as I say, there's a ton of them here at that website that you can use your video capture to capture the video as you, or animation as you play with it, and then drop it into your PowerPoint. So that would be what I have for tonight. Thank you.
Thank you, Arnold. That is absolutely wonderful. Of course, let me just grab our screen and let's see here. We'll pull back over onto the observatory slides. Not that we don't want to stay on your slides. They are really excellent. I have to say that I do feel like I need to start using the curtain transition more. And if anyone is wondering, there are lots and lots of wonderful Skies This Month broadcasts that they can find. And Arnold, are they all on the RASC TO site?
Yes, that's right. If you go to RASC Toronto, I believe you can search through all of the saved videos for all of our recreational astronomy nights. And I believe even the speaker nights are also available on the archive.
Wonderful. Well, thank you again for this absolutely fascinating talk. I think it's got tools and tips for absolutely everyone. Now we know how the magic is made with Sky This Month, and I for one am definitely looking forward to trying out a few of those tools that I haven't seen before. So we're going to go ahead and transfer over, but we'll be bringing you back on and off for a few more riddles if you don't mind.
Okay.
So thank you, Arnold, and go ahead and feel free to turn off your camera and audio. We're going to go ahead and move on to the second part of our, well, three-part fundraising evening. This is very, very exciting because not only did we have Arnold on to talk about the Sky This Month tips and tools and show us really how to prepare an excellent analysis of what's up in the sky. But we also have another guest speaker. So let me go ahead and introduce our second. So we have, and I will just say that Arnold was from RASC Toronto Centre. We now have Swapna Shrivastava from RASC Mississauga Centre. So this is great. We've got a double feature, and we've gone from talking about preparing our observing and our sky analysis all the way to looking at the sky, and in particular the C-Star S50. So I'm just going to talk a little bit about our wonderful speaker because I'm really happy to have her here. Swapna is a seasoned business transformation leader and Master Lean Six Sigma Black Belt. So over 20 years of experience in process reengineering, digital transformation, customer-centric consulting across diverse industries, including very astronomically related aerospace, semi-astronomically related banking, and lots of other things, not-for-profit. Swapna holds a Master of Engineering from McGill University, an MBA from Schulich School of Business, lots of wonderful certifications in AI, and of course, she's a lifelong learner and a proud mother of two daughters. She's also a avid amateur astronomer. I wouldn't say maybe completely amateur, professional amateur, and a member of course, the Mississauga Royal Astronomical Society of Canada. So that's our RASC. Very engaged in public outreach, and we're lucky to have her with us tonight. She's going to help us learn about one of the most popular small telescopes that no one I know seems to have, including me. I don't have one. So, Swapna, can you please tell us more about this amazing, interesting scope and your experiences with it, and maybe grab the screen share and pull in your slides as well.
Thank you, Professor Hyde, for having me tonight and for that wonderful introduction. I am about to share my screen. Please let me know when you can see it.
All right. Yep, it looks great. Go ahead and take it away.
Okay, so thank you very much for an opportunity to be here with you tonight. I will be speaking about my C-Star S50. This telescope is a gift from my husband for my birthday back in April, late April. and I have been using it for the last several months from my home in the GTA, which is a Bottle 8, which is heavily light polluted backyard. So this experience that I have is mine. And again, you may have a different experience. If you do, definitely leave some comments in the YouTube comments below. So from there, what I'd like to do is get into this a little bit. There are a lot of smart, let me start with my preferences as a user. So I'm a visual observer, have been for a long time now, but my interest lies in deep sky objects like nebulas and galaxies. I have about three visual telescopes at home, and I have tried to, I do find these objects. However, they appear as white blobs in my telescope. So while I get excited and I'm gleeful when I find these objects through my regular telescope, what I miss is those colors when I see those beautiful astrophotography pictures. So I did try a hand in astrophotography using a DSLR, etc. Unfortunately, I was not successful for a variety of reasons. I also like my telescope rig to be lightweight and portable. I don't have a lot of time to go outside of my neighborhood to view. If I'm lucky, I get out to a dark sky, but in many cases, I'm not able to. So my preference is to observe from my backyard. I also want a quick setup and teardown, and I want minimal post-processing requirements, but because I actually don't know, even though I've tried to use Photoshop and PixInsight. So as my, keeping these preferences in mind, my husband started looking for some smart telescopes for me. And there's several in the market. They have been around for the last few years, and they range from anywhere from about $500 to $6,600. Now, that's a big range. He knows my preference. I know my preference. And he selected the CSAR S50 for my gift. What I wanted to highlight here on this slide is that all of these telescopes have few things in common. They are Wi-Fi enabled. All of them have the go-to capability. All of them will do light or live astrophotography. And then again, depending on the telescope that you choose, like any other telescope, there's a lot of different features. So you may want to take a look at some of the references I've given below, or even just do a Google search to see what might fit you and your preference and your budget. For me, it was the C-Star S50. Now, there's a lot of bullets here. Unlike the previous speaker, unfortunately, there's a lot of bullets over here. And that's because I wanted to put out a list in case you wanted to pause the video and kind of read through this. Inclusions and specifications. I won't go through the entire list, but I want to highlight a few things. The C-Star actually comes packed with a number of features, including a solar filter for sun viewing. It has an exclusive app, and it is ready to use outside of the box. I typically use the stargazing and the solar system modes. There's a fantastic lens on it, which is a triplet APO. It's a focal length of f5 and a 250 millimeter focal length, which is a pretty decent size for a telescope. It's got a built-in astro camera, which I actually never had before. I had a DSLR, but the aperture is a little bit limited at 50 mm. It has fantastic features such as go-to live stacking, autoplay solve, autofocus, and auto dew heater. If you were to buy the telescope and buy these individually, like the dew heater, you would be paying extra for all of these features. Moving on, it also has three built-in filters. If you were to have a regular telescope, you would be buying these filters individually, as I had when I had the regular telescopes, but these all come built in. It's a lightweight, it's about 2.5 kilograms, so it checks off the box for being lightweight and portable. And the picture formats are JPEG, but you also get raw images that come out of this. This is currently ranging for about $630, I believe, for Black Friday. 630 Canadian plus tax, and most of our astronomical stores carry this particular brand. You also have to consider what it doesn't come with. So every telescope has advantages, and there are other considerations. And the question becomes, how important do these considerations are for you personally? As I said, I'm a visual astronomer, and it doesn't have an eyepiece. You do have to, when you see the picture, it actually comes out on a screen. It's not a deal breaker for me because if I want to go and watch or do visual astronomy, I have another telescope at home to choose from. It is an alt-az mount and it doesn't have an EQ mount. Again, could be a deal breaker for you. It has limited exposure times, and it's also what I found is not adequate for planetary observations. And the photos that come out of it are usually portrait mode, but that's again solved post-processing. You just flip the picture to get a landscape mode should you wish. The features that I have not tried. See, the C-Star, like any other telescope, they do push software fairly often, so you do get updates from now and again. And recently, they pushed the framing or the mosaic mode into C-Star. I have not had a chance to use it just because of cloudy conditions in my area. But you'll see in the picture on the right, there's a blue rectangle around the nebula. If you were not to use this framing mode, you would actually get only a part of the nebula, which is actually part inside the blue rectangle. In the framing, from my understanding, is actually to cover the entire nebula, which is kind of cool, and I'm wanting to try it out in the next available night. I also haven't had a chance to try the 20 and 30 seconds, so the pictures I'm about to show you in a few minutes is about 10 seconds long. Sorry, they're 10-second frames. So my experience using the C-Star, I have used it for both the solar system and the deep sky since beginning of May. I would say it's good for the sun and includes a solar filter. Personally, I have until I got the C-Star, I had never had a chance to do any sort of solar imaging, or even, I used to go out into an outreach program to look through another telescope to see the sun. So that's kind of cool. I can do this from my backyard now. It's great for the moon. No filters required. Again, I'm going to show you a couple of pictures. One of the things to keep in mind, and this could be a personal thing that happened, but it took a few attempts to find the sun and the moon. But when it did, it just takes a few minutes. But when it did, the auto tracking lasts for about 20, 30 minutes, which is kind of cool. And you can get a lot of great pictures, both of the sun and the moon. Great for bright comets. Again, like I said, from a planetary perspective, I found that both Jupiter and Saturn were washed out. You saw them, you got them, but I could not see the bands of Jupiter. Northern Lights, back in May and more recently, I did try using the C-Star to capture Northern Lights. Again, that was a no-go. It saw right through the Northern Lights. Deep sky, however, which is, remember, my preference was to see some deep sky objects. It's fantastic for that. And again, I'll show you some pictures, nebulas, globular clusters, and galaxies. Post-processing, like I mentioned, you can capture raw images, and if you so wish, you can use Photoshop or PixInsight. I don't do any of that. I take the JPEG that comes right out of that, out of the C-Star, and I use the Apple's native photo corrections like crop or noise reduction just to adjust that picture. So my workflow, I usually have it already charged up and ready to go. It's a very small little thing. It's maybe, 2 feet high. It's very, very small, very light. I have a power bank at home. I've had it for a while, but you can basically charge the battery and keep it ready to go. The battery is about 6 hours. It lasts about 6 hours of viewing. What happens is I poke my head out, see if the backyard, which is where I typically view from, is it clear? Yes, it is. I take the C-Star out, put it out, make sure that it's adjusted and calibrated. So, balanced and calibrated. Usually takes a few minutes. I turn on the Wi-Fi, and then I connect it onto my iPad. I have an older iPad, a 9th generation. There's an app right on the iPad. I can either pick the object from the C-Star app, it has a catalog, or I will use my Sky Safari app just to pick what I want to look at for that particular evening. And then from there, I make sure the picture starts capturing. Once it's done, it does this thing. I go and stay warm in my kitchen or elsewhere in the house while the C-Star is working out hard in the cold, or in the summer when the mosquitoes are out and about. I'm actually inside, quite safe in my house, either viewing through my iPad screen or doing my own thing to come and capture that picture later on. Once the picture is done, then I will, like I said, I'll do some adjustments to it, and then I share with family, friends, and my RASC member friends. So let's get into the pictures. I'm going to take you through the solar system. These are pictures, the 2 pictures on the left, which says 2nd May and 7th May, are actually from the C-Star. I had this telescope only for a couple of days when I took it out and I tried to find the sun. keeping the solar filter on. And lo and behold, it was a quick capture after a few tries. You'll notice that there are some sunspots right here and right here. I was so amazed to see them, and I'm like, this can't be real. So I went to the internet and I actually pulled up what was, the solar picture. The picture on the right is actually from the internet from 7th of May. And look what the sea star was capturing that I was seeing from my house to what, I was seeing on the internet. It was awesome. So I knew that I had captured the sun and I had captured the sunspots as expected. And this was the famous AR3664. For those who don't know, this is the sunspot that caused the X flare and eventually the massive auroras or northern lights that we saw back in May in Ontario, southern Ontario to be specific. So this was the sunspot that caused this beautiful phenomena of the northern lights back in May. Moving on, the moon. You'll notice that with the moon and basically a solar system, you can do 1x, 2x, or a 4x zoom. You can also do video. So I just wanted to show you a 1x zoom and a 2x zoom and then a 4x zoom. And you'll notice I've called out a few features of the moon. I have finished or completed a certificate from RASC, which is Explore the Moon, a certificate where we had to actually learn the craters and the different features of the moon. And my favorite is the Apennine Mountains. These are named after the mountains in Italy. And you can actually see these mountains. You can actually see them from a good telescope at home, a regular telescope, but it was really nice to get a picture and then be able to really look at the moon and the craters and kind of go back and do some cross-referencing after the fact against the things that I had learned through the certification program and just refresh my memory. This is Mare Tranquility, or the Sea of Tranquility, where, of course, Apollo 11 landed back in 1969. So that was kind of cool. We'll stay with the solar system for one more slide. This is Comet A3. The Comet A3, of course, came around in October, a bright comet. This is a photo courtesy of my friend, Michelle, who actually purchased a sea star after seeing mine. And this picture, it's only 1 minute, and it was a bright comet, and it did a fantastic job of capturing the tail and the head of this particular comet. So that was kind of cool. And then now we're going to move on to deep sky. So we'll start off with globular clusters. So globular clusters are tightly bound clusters. There are about 150 globular clusters that orbit the Milky Way. I'm showing two of them here, the M13 on the right and M3 on the left. The M13 actually I've seen using binoculars or a regular telescope appears as a white glob, white blob, but it was really nice to start seeing some resolution and some stars coming out during the visualization. It's about 11 minutes of data. They're fairly bright at about 6 magnitude, both of them. Both of these globular clusters are about between 25 and 34,000 light years away from Earth. So the other thing I wanted to highlight also is these circles that you see here. What the sea star does is it actually will put a circle around your target. It'll name the target. While I was viewing M3, it actually also captured another object, which 5263, which is, of course, very faint and very hard to see, at least from what I was looking at. So that was kind of cool, I thought. Moving on, these are planetary nebulas, and nebulas are my favorite objects in the sky. And these are two separate planetary nebulas, the Ring Nebula, the M57 in the Lyra constellation, and the M27. Fairly dim objects. They're about 1,000 to 2,000 light years away from Earth. Planetary nebulas are, of course, dying stars that emit radiation, and these cosmic dust and gas, when it interacts with the gases around it, cause these beautiful colors, blue from oxygen and red from hydrogen. So again, absolutely gorgeous job. Not that much time, 10 to 7 minutes. The other thing I want to talk about is when I talk about 10 minutes or 7 minutes, this is actual light frames. Basically, this is actual data that has been used to produce this picture. You may, if I'm taking 10 minutes, it's possible that I'm actually sitting, the telescope's actually looking at that object for about 20 minutes. And you'll ask, why 20 minutes? Well, the data is only for 10. Well, what it does, it actually stacks these photos. And if a satellite goes through, for example, it will stack and it will try to get rid of the satellite trail that you're seeing. It doesn't do, like, it's hard sometimes because the satellite trail is really, really bright. It's hard for the telescope to get rid of that trail, but it will continue to stack. The more stacking you can do, basically, the more data you capture, the better information and the better picture you get at the end of the day. One of the things that I should mention also is because these are only 10 seconds, each frame is only 10 seconds, eventually you will start to get, it's an alt-as, you will start to get that field rotation, but that's again easily fixed by just taking that, the edges out of the picture. Galaxies. So this is the M33 Triangulum Galaxy. I took this not too long ago. It's about 3 million light years away. 55 minutes of data and absolutely stunning. It is a dim galaxy. What I wanted to do is I wanted to take a picture of this galaxy, then compare it to the one that's available on the internet. And this one was from NASA. And you'll see the structure coming out of my telescope from Oakville is similar to what I see published on the internet. So I was quite happy with that. I was happy with this picture. Nebulas. So I have two sets of nebulas, one of them in the summer season and another one more in the late fall season. So I'm just going to show you a couple of pictures from the summer first. This is the Trifid Nebula. Again, seen it through the binoculars, appears as a white blob. This particular nebula is in the Milky Way arm. It's the M20 in the Sagittarius. Its magnitude about 6. It's about 9,000 light years away. Nebulas, of course, are stellar nurseries. That's where stars are born. And this is an emission nebula. And those dark lanes that you see are dark lanes of visible dust. And in fact, you see a streak of satellite going right there. So you'll see that. And that's, again, something that, just is reality of life these days. Next one's the M16 or the Eagle Nebula. And you'll notice I've circled a couple of objects, and I'll talk about that in 1 second. But this is about 6,000 light years away from Earth. Again, a star-forming region. Again, a beautiful object in the Milky Way band. The story goes that I was sitting and watching this live picture come through because I wanted to see. Then I started seeing this object here with the wings and what looks like a little head. I'm like, that looks awfully familiar. So, I went looking for it on the internet and I'm like, and I fell out of my chair. Well, why did I fall out of my chair? Because I was looking at the pillars of creation from my kitchen table in Oakville. And I'm like, oh my goodness, this is awesome. And, here we are, Pillars of Creation, the very famous Hubble picture that, of course, is, made Hubble very, very famous. And the next one here is the Stellar Spire, apologize. These are the most recent pictures that I've got, the Orion Nebula, which is the M41, and then, M42, and then you've got two other nebulas over here, M41 and 43, again, star-forming regions. This one here is interesting. It's the Horsehead Nebula, usually difficult one to get from what I understand. You'll see the picture of the horse, or the head of the horse over here. Only 8 minutes of data, and that's because, again, the clouds started coming in, so I had to pull in the sea star and stop observing. But I do hope to get a better picture in the near future. So that was very impressive of this telescope. So that's the end of my pictures, but I just wanted to give a shout out to my center, the RASC Mississauga Center. We do a number of outreaches starting late spring to early fall. We are based out of the Mississauga area. We go to Riverbird Conservancy and we do public outreach. So if you're in Mississauga in the summer, you can always check out the Riverbird Conservancy and see when we're going to be out, and we bring multiple telescopes for you to come look through. And we have a number of great amateur astronomers who are willing to share all their knowledge with you. And we also partner with the University of Toronto and Mississauga, and we do outreaches there as well. We're about 200 members in the Mississauga, Oakville, Milton area. And we started this center back in 2003, and we became part of RASC in 2006. So just to close off, just a reminder, I'm a visual observer, and the sea star absolutely checks out the boxes for me as a user. And it is a great fit for my abilities. I call my sea star the dream star. Thank you.
Thank you so much, Swapna. Let me just grab this screen back, and it has been wonderful to see your experiences with this. There we go. All right, so it was great to see your experiences with the Sea Star, and of course, as a handy reminder to anyone who is thinking about getting into amateur astronomy, the RASC in Canada is a great resource, and there almost certainly is a center somewhere near you, whether it's, if you're in Ontario, of course, we have Toronto, Mississauga, and many more. So it's a wonderful resource for everybody who in Canada who's interested in teaming up and finding out a bit more. And I think the Sea Star is very, very much one of our up and comers. I'm glad to know a little bit more about it. It's really one of the new small telescopes and just looking so, so very portable as well. So we do have one question coming in, looks like, about Swapna's talk. So Swapna, just as a little extra, can you tell us how you focus the Sea Star?
So I actually don't. The Sea Star does the job itself. So what happens is it's got the autofocusing on it, but you can also, what happens is when it finds the object and you don't like what you're seeing, you can hit autofocus. So that's one way. The other way is on the left, there's a dial where you can dial up and down a little bit until you get the picture that you're looking at. Honestly, for me, I don't do very much at all. It's very rarely that I actually have to force any sort of focusing. And the solar system objects is a little bit more, but in deep sky, it does a great job on it. So, and the pictures that you're seeing are just JPEG pictures with very minimal corrections on them.
Oh, wonderful. So this is really automatic mode, very, very different from what some of us might have seen, especially if you've ever been out to the Allan I Carswell Observatory and looked at the 60 centimeter, which is a telescope from 1968. So the older they are, the more manual corrections they require. This one looks like a really, really different beast. So thank you very, very much. This has been a wonderful sort of a jaunt into small telescopes. So for our next quick transfer item, I do just want to take a moment to remind everyone. Welcome to the Allan I Carswell Observatory special fundraiser episode. We do have a lot of wonderful things going on this month due to our fundraiser, which is going all the way until January 5th of 2025, the new year. And we have special events. And one of the things that's often asked is, of course, why support the Allan I Carswell Observatory? We do actually sometimes do very, very large events as well. So I've put in a little picture from one of our solar eclipse events. Actually, this is a partial solar. In 2024, we had a major solar eclipse extravaganza. And I believe lots and lots of RASC members were also traveling because if you didn't hear, in 2024, we had a total solar eclipse going through parts of Ontario. So people were traveling to get to totality. People were taking great, great, great pictures all over. Of course, we have a little observatory website dedicated to some of the astrophotography and events. And these kinds of large events are also something that you can support with our current fundraiser, which is, of course, on that same website I mentioned before, yorku.ca/science/observatory. The observing raffle and the private tour raffle are both open, so feel free to hop in. Now, in order to get us to our next item, we do have a little bit of fun again. So you will all have to excuse me if I make this a little bit of a quiz show. But we have another observatory riddle coming in. So this is again on the side of the slide that you're reading along, but the observatory riddle, can you guess, what am I? I'm red, but I'm not a stoplight. I'm named after a Roman god, but I'm not Apollo. I have a Mount Olympus, but I'm not Greece. I have polar ice caps, but I'm not the Arctic Circle. So actually, I'm going to just ping Arnold. Would you like to come in again and give a try at this riddle? If you're
Hello.
Hi.
Yes. Hi.
So I'm just going to read it again, just in case
Yeah.
anyone's following along on YouTube. But the riddle is, what am I? I'm red, but I'm not a stoplight. I'm named after a Roman god, but I'm not Apollo. I have a Mount Olympus, but I'm not Greece. I have polar ice caps, but I'm not the Arctic Circle. So do you
Mhm.
have any guesses?
Well, it's the last one that I think kind of gives it away because I know we all know that Mars has polar ice caps and it seems to check all the other boxes. So I'm going to go for the planet Mars.
Yeah, that's exactly the astronomical answer I was we have written down as our suggested solution. So I'm glad you picked Mars. It's also my favorite planet. So if you knew that already, you'd have a good chance of guessing it. But yeah, very red, of course, due to the iron oxides on its surface. It does look red in the sky. Wonderful object to view. This winter, it's going to be quite nice. And of course, the name Mars comes from a Roman god, and the Mount Olympus is right up there. So you have several very, very famous, extremely high mountains on Mars. It has the highest mountains, the largest canyon, some very extreme features. But yeah, I think you're right. The polar ice caps really give it away. And of course, the polar ice caps changing over time. We could have even added a line about that, maybe. So, so for anyone playing along over on the YouTube chat, um, we'll go ahead and you know write that down as a point if you got it. So, all right, thank you very much. Let's go ahead and move on. So Mars, I could probably do a whole other talk about that, but that might be a different fundraiser right there. Actually, I have one. It's called Mars Rocks, but that's not in the news today. So next section we have is a special. This special episode, we've got a lot of things going on. We had two amazing guest talks, but we've also got breaking news. So this is the breaking news section. Welcome, everyone, to Breaking Astronomy News from Allan I Carswell Observatory. We have three amazing stories, recent in astronomy news, brought to you by our amazing crew. And of course, we're going to start off this series with yet another astronomy riddle before we go into the news session. So this time I'm going to ask Swapna, would you like to come in and give it a try? I'm going to go ahead and do the first reading of the riddle. So if you're following along online, this is a text at the bottom of the slide. The observatory riddle is, and this is another, what am I? When looking at the night sky, you'll be able to see the moon, but you might need to use this if you want to see Neptune.
Well, it's certainly not the sea star. So it's got to be a telescope, maybe a regular one, perhaps.
Well, you could say sea star because that was your talk topic. So I think this is a good one. So and we'll just read it again. When looking at the night sky, you're able to see the moon, but you might need to use this if you want to see Neptune. And we'll just go ahead and call back to our earlier talk about what's up in the sky tonight. Neptune is actually up there in the sky above Toronto this evening. And if it was totally clear and you could see the stars and you could see Jupiter, you still would not be able to see Neptune because your eyes are not that sensitive. So your sea star would be a possible solution. And generally any telescope would work, but, and we'll go ahead and give some props to Arnold who mentioned this before, there are some very good binoculars that would do quite a nice job with Neptune as well. So we'll go ahead and say telescope and with an amended riddle answer of binoculars or optical assistance. So telescopes would, of course, be my favorite answer because one of the favorite things I like to say is if you're traveling around in outer space, telescopes really do make the best spaceships. So anyways, if you all forgive me for my telescope jaunt, we'll go ahead and get started with some amazing news items. That's right, three breaking stories, all very recent, and all this year. 2024. First up, we have a wonderful story by Maheen about a real mystery that has occurred. So Maheen, why don't you go ahead and take it away?
Thank you, Dr. Hyde. So, for our very first news item, I would like to talk about the mysterious little red dots, which I found to be very mind-blowing objects that have been found this year. So, those working with the James Webb Space Telescope have recently, in March of 2024, reported the discovery of galaxies called the Little Red Dots. This was observed by a team led by scientists from Penn State University when investigating the early universe using JWST's Near Infrared Spectrograph instrument, NIRSPEC for short, as part of the Ruby survey. These are a group of small red-tainted galaxies located in one of the oldest regions of the observable universe. And they're not just any galaxies, they are incredibly odd as they consist of stars that are too old to have lived during early cosmic times. Not only that, but they consist of black holes that are thousands of times larger than the supermassive black hole at the center of the Milky Way, which is our galaxy. The little red dots, LRDs for short, are seen as they were when the universe was between 600 to 800 million years old, which is very young. So, for reference, the universe is currently 13.8 billion years, and LRDs were observed only within the first billion years of the universe's formation. So the formation of these galaxies has to be as peculiar as their properties. It is believed that these objects must have been born in a unique way in comparison to the other objects in the early universe. It could have been a method of formation that ceased after around a billion years of the existence of the universe, but nothing is known for certain so far. So this is currently a new puzzle astrophysicists are trying to solve, and hopefully exciting discoveries are to follow. So for our next news item, I will hand it over to Dave, who will be talking about some other fun space news.
Thank you, Maheen. Moving on with the second news item. Uranus's swaying moons will help spacecraft seek out hidden oceans underneath the surface of the moon Miranda in particular. A new study published in the Planetary Science Journal in October revisited images taken by the old Voyager 2 spacecraft, the only to visit, and claims that Miranda's geology results from tidal forces from neighboring moons. Similar to the pull of the Earth's tides, gravitational tugs from nearby moons deform Miranda and create friction and heat that keeps the interior warm, also creating stresses that crack the icy surface, making the moon a rich tapestry of geological features. To come to that conclusion, a team of scientists figured out what the Miranda's interior must have been like to produce the surface feature seen by Voyager 2. The best match was a vast ocean at least 62 miles, 100 kilometers deep, beneath the moon's 19 miles, 30 kilometers thick icy crust. In 2021, NASA proposed a mission to Uranus to investigate if its icy moons have liquid water ocean underneath the surface, which can potentially support life. Researchers from University of Texas Institute for Geophysics are creating a computer model to assist in finding these oceans from spacecraft cameras. This model analyzes changes in the moon's spin to estimate their internal form, including the depths of this ocean and the surface ice thickness. A rare planetary alignment of Neptune, Uranus, and Jupiter will soon provide a rare window to send our spacecraft on a slingshot via Jupiter, Uranus on a journey that would be shortened to 11 years. However, any spacecraft would need to leave Earth by 2034. With the suspected moon on Miranda, planetary scientists now think Ariel, Umbriel, Titania, and Oberon could also have subterraneous oceans. If these oceans are actually discovered on the Uranus' moon, it will blow the concept of where life can exist, especially considering such ice giants are quite abundant in the galaxy.
Thanks. That's a wonderful news items. Moving on to our next, we're taking a short aside. Um, of course, breaking news in the amazing possibility of actually getting some information for Uranus, which I might add is critically understudied at the moment. And of course, those little red dots are so mysterious. You just look at the picture and go, what on earth could this be? And that's what everyone is saying, which makes it super, super fun. All right, so we're going to take one little extra riddle on our way to the last news item. And I'm trying to keep track, but let's go ahead and see how it goes. This one's maybe a little bit harder because the answer is not Mars, and that's actually in the riddle. So this is a what am I? I have the atomic symbol Hg, but I'm not hydrogen. I'm a metal, but I'm not gold. I'm a liquid, but I'm not solder. I'm a Roman god, but I'm not Apollo. And I'm a planet, but I'm not Mars. So definitely not Mars. Arnold, are you interested in coming back in on this one?
Hello. Hi. Let's
Welcome
see.
back.
Yeah, thank you very much. Great show. I'm really enjoying this tonight.
You have it. Let's go ahead and do the riddle one more
Well,
time. And
alrighty.
it's going to be a what am I here?
Yeah, I think this fellow might be Mercury. Am I right?
Yes, indeed.
Oh, good.
It is Hg, so Mercury. And if you think about it, looking at what kind of planet could it be? If we rule out Mars, well, Earth isn't a metal, and neither is Venus. And we just heard about the icy outer solar system, so it really must be Mercury, which of course was also a Roman god. Just in case any of our listeners aren't up on their mythology recently. So that's an excellent guess. And of course, it's not Mars, so I put a picture of Mars there just to mislead everyone. Alrighty, everybody, thanks for following along on this exciting fundraiser evening. We're now going to hand off to our very, very last special news item, a breaking news from astronomy, very, very recent. Take it away, Hector.
All right. Thank you, Professor Hyde. Well, moving on with another interesting news. For the very first time, a group of astronomers led by Keiichi Honaka were able to obtain a zoomed-in image of a red supergiant star. The main target of this great advance was the red supergiant WHOG64, also known as the Behemoth star, with a mass of 2,000 times the mass of our Sun, located 160,000 light years away from us, in the Large Magellanic Cloud, a satellite galaxy of our own Milky Way. Thanks to the efforts of the team behind the ESO's Very Large Telescope Interferometer, or VLTI, located in Chile, they were able to obtain this zoomed-in image of the Behemoth star, which is on its last stage of its life. The image revealed an unexpected egg-shaped cocoon of gas and dust surrounding WHOG64, as you can see on the image, which may be related to the star's evolution, which is thought to be in the final stage before a supernova explosion. The observation demonstrates the impressive capabilities of the VLTI, particularly its gravity interferometer, which combines measurements from several telescopes to allow astronomers to achieve the resolution needed to image a star at such an immense distance. This discovery provides a rare opportunity to witness a star's life in real time, as the team found that WHOG64 has been experiencing significant change over the last 10 years, becoming dimmer along that time span. Consequently, this breakthrough opens up new possibilities for studying the life cycles of stars in other galaxies, potentially leading to a better understanding of stellar evolution and the processes that occur before supernova explosions. The team plans to conduct follow-up observations using ESO's instruments, which will be crucial for understanding the ongoing change in WHO G64 and potentially witnessing the lead up to a supernova event. Thank you, Professor.
Wonderful. Thank you for that great news item. Very, very exciting. Now, before I move on to one more final riddle, I suppose, I'm just going to go ahead and ask our wonderful team and, of course, our amazing guest speakers, do you have a favorite news announcement from today? Arnold, I would just ask you first if you would like to hop in. Are there any of the news items that you would say are your personal favorite at the moment?
Oh, those news items, they were fantastic. I like the one about the little red dots. I thought that was amazing. What we're learning with our space-based telescopes as well as the huge ground-based telescopes is fantastic. And there's one more gargantuan telescope about to go online, I believe. I forget its name, but it might be the last of the huge Earth-based telescopes to be built.
Yeah, I
Yeah.
actually saw some pictures earlier today. There's a few social media accounts, I believe, on Mastodon that have been posting pictures of it as it goes up. But yeah, the amazing things that we're able to see now that we have not just JWST, but also larger ground-based telescopes and networked telescopes. It's really bringing out details that
Mhm.
we could never have seen before. And of course, finding things that people really don't understand, which is one of my favorite things in astronomy.
Mhm. Yeah, we're
Amazing.
always learning new things and throwing away what we thought we knew.
Exactly. And that is, I would say, definitely part of the fun. All right, so I'm going to go ahead and ask Swapna as well. Swapna, if you're here, do you have a favorite of the astronomy breaking news items?
Yeah, the last one was very interesting. The close-up of the sun. This one. Oh, this is just beautiful.
Yeah, actually getting images of another star. And this is something that people don't realize just how incredibly small these things are. The distances in space are absolutely vast, and this star was literally not even in our galaxy. Our galaxy, the Milky Way, contains almost everything that you can see in the entire night sky, except for the LMC and SMC and Andromeda and a dark sky site. But literally outside of the galaxy, 160,000 light years away, I believe was what they said. And creating an image that's detailed enough that has the resolution to actually be able to see a real size on a star that's not our sun is incredibly difficult. Huge technical challenge. So I absolutely agree. This is one to watch out for. All right, well, since Swapna picked this one, I'm going to go ahead and pick as my own favorite object the icy moons of Uranus and the Uranian system in general, as well as the Neptunian, just so critically underexplored. We need to send a spacecraft out there and examine some of these icy moons and how many of them do have oceans. That would just be so cool. Oceans all over if it's true. So we're really looking forward to all of those. All right, so it looks like we're just pulling in to the end of the show. So we have one final riddle. All right, so I didn't save, I wouldn't say it's the hardest riddle, but it is maybe the most mysterious. So we're going to go ahead and remind everyone, thank you very much for coming today to our special fundraising episode. The Allan I Carswell Observatory does free outreach every week, every Wednesday in person, every Monday online. We have a radio podcast, and of course we do this teletube show, as well as in-person tours, school projects, student observing, research observing, galactic archaeology, subdwarf B stars, SX Phoenicia stars, you name it, we've done it, including actually tracking JWST across the sky. So if you want to support us and help us do some repairs, please see that fundraiser page. And of course, enter yourself into some of the raffles for a chance to win. There will be a free winner every time we hit a goal. So the last riddle of the evening, the observatory riddle. If you're reading along on the screen, it's a text on the side. This is a what am I riddle. Okay, What am I? These are giant balls of gas, many light years away. Most are only seen at night, although one's seen in the day. And Swapna, I'm just going to bring you back for a second to give you a chance. Would you like to take a guess on this one?
I would think it's our sun. Would I be right?
Well, the last line in the riddle, I think you're close. So the riddle is, and I'll just go one more time. These are giant balls of gas, many light years away. Most are only seen at night, although one's seen in the day. And since this is the last riddle, I thought it might be fun. Arnold, would you like to hop in as well?
I'm wondering if this is tough because the sun's not many light years away.
Yeah, it's the but one's seen in the day, which does sound like what Swapna said, right?
Star, perhaps? Stars?
Stars, yeah. So we'll go generic. Arnold?
Yes, I'm still
All right.
stuck. I'm just wondering if there could be like a supernova so bright you could see it in the day.
Yeah, absolutely there could be. And I think that there are some simulations that we could probably refer to that would show us exactly which supernovas that would be possible on. I believe I forget what they said the magnitude of T Corps would be when it exploded, but it was quite bright. I don't know if it was daylight brightness or not. Um,
But the
but
ones
yes,
that the one that was seen in what was it, 1030 something or other? I think
yeah,
the Chinese astronomers recorded it.
yes, exactly. So it has happened before. It will happen again. But supernova are notoriously unpredictable. So we could say supernova, which are of course created by stars. And if we go generic, then these are giant balls of gas. Many are light years away. Most are only seen at night, although one's seen in the day. So if we go for generic, the most generic definition of star or main sequence star, then I think we would probably fill it, the criterion. Um, all right, so the official answer is, as of the ones that I wrote down earlier, stars. But we would take main sequence star, and with a note that, as Arnold mentioned, supernova would actually help make it more than one in the day. So um, if that happens, this riddle may no longer be valid, and you may apply for a riddle refund by emailing observe@urq.ca and telling them that it was Dr. Hyde's fault. All right, thank you everyone for joining in for our amazing fundraising. I will like to just go ahead and tell folks this is not the only event that we will be doing. We will be having Wednesday night in-person tours for free. The tickets are on the website. If you are in Toronto area and would like to come and see a tour of the observatory, you're welcome to stop by. And you have all been listening to the Allan I Carswell's Teletube special fundraising broadcast. We have had an amazing show, and our next special fundraising YouTube event online will be December 18th, where we will be doing a similar idea of fundraising YouTube, but we're actually going to have games. That's right, astronomy games. So if you thought the riddles were fun but too easy, you should definitely come back on December 18th, where we will be playing not only Astronomy Jeopardy, but Astronomicers and One Step Astronomy, which are probably a little more difficult and occasionally very hilarious when people try to do them too quickly, which is why we always encourage people to do them as fast as possible. So this wonderful broadcast has been put together by many folks this evening. I'd like to give a special shout out to my incredible crew for sticking with me on this unusual event. So thanks to Maheen and Dev and Hector, and a very special thanks to our guest speakers, Arnold Brody from RASC Toronto Centre and Swapna Shrivastava from, of course, RASC Mississauga Centre, double feature RASC presence. All right, everyone. So we're going to go ahead and end off the evening now. Just as a reminder, all of our programs are in fact free, but if you would like to make a donation and help out the fundraiser, please see yorku.ca/science/observatory. You can always connect with us on Instagram at York Observatory and, of course, Facebook at Allan I Carswell Obs. See our website for show notes, content updates, that fundraiser I keep mentioning, and, of course, contact info at yorku.ca/science/observatory. If you have any questions for our speakers tonight that did not quite make it into the show, you can email observe@yorku.ca and we'll pass your questions along to our speaker, or you can post them in the description into the video and we'll post the answer back to you at some point. So thank you again for joining in. Thanks for tuning in and of course sticking with us. Clear skies and have a wonderful night, everyone.